Let's stop for a minute and just think about what we're talking about when we refer to the sampling distribution of means. Now this is a normal distribution. You recognize this. You've been working with this for a few chapters now, right? Now previously we were using the normal distribution to represent the frequencies of individual cases. In other words, on the y-ordinate were frequencies of cases associated with each of these points on the normal distribution, right? Down here we have our z-scores. In this chapter, you're working with something different. Now, in this chapter, we're using the same normal distribution to represent something different. We're using this distribution to represent a distribution of sample means. Now, what does that mean? Well, let's say you go out and you test 100 subjects and you get motor reaction time on a simple motor reaction time test for 100 subjects, and you get the average of all of those 100 cases, and that's one sample mean. Now you go out and you do it again. You get another 100 subjects. You test their motor reaction time. You get one value from that sample of 100 cases. That's the average value or the sample mean for that sample. That's two sample means. This distribution, when we're using it to represent the distribution of sampling means, is representing an infinite number of sample means. Fine. Now, when you use the normal distribution to represent sample means instead of individual cases, there is a very important difference. In the sampling distribution of means, z-scores are equivalent to the standard error of the mean. And the standard error of the mean was just introduced a couple pages ago. Standard error of the mean is, remember, calculated by taking the standard deviation of your sample divided by the square root of the sample size, right? We go ahead and put capital N there so it's clear. All right, so it's the standard deviation divided by the square root of the sample size. Now notice something, isn't that interesting? We're estimating the standard error of the mean based on your sample characteristics. Okay, so what does this mean in practical terms? Well, when you're doing the exercises in the coming pages, this means that when you're converting a mean value to a z-score, remember in the previous chapter you were converting individual scores from a test to a z-score. Well, now you're going to be converting mean values to a z-score. You must subtract the population mean from the sample mean and divide by, not the standard deviation, but the standard error of the mean. And when you're determining the mean associated with a given z-score, right, which you did in the last chapter, you must multiply the z-score by the standard error of the mean, not the standard deviation.